Ever wonder what goes into building a modern factory? It's not just about bricks and mortar. Think of it more like a giant, super high-stakes puzzle. Every single piece has to fit perfectly, because one wrong move could literally cost millions. So today, let's try and solve that puzzle. We're going to build the perfect factory from the ground up.
Right, so where do you even begin? How do you take an empty patch of dirt and turn it into a buzzing, high-tech production powerhouse? Well, the whole journey, believe it or not, kicks off with one single decision, and it's a big one that shapes everything that comes after. And that brings us to the first and arguably the biggest piece of the puzzle: location, location, location. I mean, it makes sense, right? Before you can even think about what's going on inside, you have to figure out where the whole thing is going to be. It's truly the foundation of the entire project. But it's not like you can just throw a dart at a map and call it a day. Nope. Picking the right spot is this huge balancing act. You're juggling a ton of different, often competing factors. And if you get that balance wrong, you could sink the entire project before you've even broken ground. And this really breaks down what that balancing act looks like. On one hand, you've got the cold, hard numbers, the economic stuff. Things like, how much are we going to pay our workers? And how close are we to the people who buy our stuff? But then there's the other side of the coin, and you ignore this stuff at your own risk. I'm talking about things like community attitudes. Do people want you there? And navigating all of the environmental rules. A big protest or a regulatory shutdown can be just as expensive as a high payroll. The real win, the sweet spot, is finding that perfect harmony between both. Okay, so let's say you've nailed the location. You found the perfect spot. Now the puzzle moves inside. We're talking about the layout, how you arrange everything within those four walls to get the absolute most efficient flow possible. Honestly, this is where the real magic of industrial engineering happens. So how do you even begin to tackle that? Well, you start with something called a relationship chart, or a REL chart for short. The best way to think about it is like a cheat sheet for your departments. It tells you who needs to be close to who. For example, shipping and packaging, yeah, they need to be right next to each other. But the super noisy metal stamping machines, they should probably be as far away from the quiet admin offices as possible. This chart literally becomes the logical backbone of your entire layout. From that chart, the whole process unfolds in two main stages. First up is the block layout. This is your bird's eye view, right? You're just drawing big general shapes. This block is assembly, that one is shipping. It's pretty high level. But then you zoom way in for the detailed layout. And this is the nitty-gritty. We're talking about the exact placement of every single machine, every workbench, every little piece of equipment. It's the final blueprint. And just to be clear, none of this is just guesswork. There's a whole structured methodology for this called systematic layout planning, or SLP. It's basically the science of arranging a space to squeeze out every last bit of efficiency. The goal is to get rid of any wasted movement, any wasted time. It's all about making every single square foot of that factory work for you. So here's that SLP process laid out for you. You can see how it flows logically, step by step. You start by analyzing those relationships we talked about. Then you create that big picture block layout. And then you refine it into the detailed layout. But, and this is really the key, look at that last step. Evaluate and improve. A factory is never static. There are always new products, new machines, new processes. So the best layouts are never really done. They're living things, constantly being tweaked and improved. All right, so you've picked the perfect location. You've designed a flawless layout on paper. Everything is exactly where it should be. But a factory isn't a static blueprint. It's a dynamic, living thing. So that begs the question, how does all the stuff, the parts, the materials, actually move through this perfect space? And that question brings us to our next piece, movement. You gotta think about material handling. If the factory's layout is its skeleton, then the system for moving things around, that's the circulatory system. It is the lifeblood, pumping materials and products from one area to the next. It's what connects all the dots and makes the whole thing work. Generally speaking, these systems come in about three main flavors. First, you've got your foreconveyors. Think of those assembly lines you see in movies, perfect for a steady stream of the same kind of stuff. Then you've got overhead systems, like giant cranes for lifting really heavy, massive things. And of course, you have your industrial trucks. The good old forklift is the classic example, which give you tons of flexibility to move pretty much anything, anywhere you need it. Now I want to talk about one of the simplest but most genius ideas in all of logistics. It's called the unit load. The thinking is, why on earth would you move 100 little boxes one by one when you can just stack them all on a single pallet and move them all in one go? It sounds so obvious, but this one concept totally changed the game for material handling. It cut down the number of trips needed so dramatically, it's hard to overstate its impact.
So, with all these options, how do you actually choose the right equipment for the job? Well, engineers basically go through a mental checklist. First up, the product itself. What are you moving? Its size, its weight, its shape, all that matters. You're not going to use a giant crane to move a feather, right? Second, the operation. How far does it need to go? What path will it take? And third, as always, is the cost. It's that classic business dilemma. Do you spend more upfront for something that's cheaper to run or go for the lower initial investment? Okay, let's recap. We figured out where to put the factory. We've designed the perfect internal layout. We've even established how everything is going to move around inside it. This brings us to the final piece of our puzzle. And it's a big one: automation. This is the part where the puzzle almost starts to solve itself. And if you want to see the future of material handling, well, you don't have to wait. It's already here, and it looks something like this. What you're seeing are automated guided vehicles, or AGVs. Think of them as self-driving robots for the factory floor. They're like little robotic couriers, just zipping around 24/7, moving materials exactly where they need to go, all without a human driver in sight. And the benefits of these things? They are an absolute game changer. For one, their precision is just off the charts, way more accurate than a person could ever be. Plus, they're super flexible. Need to change a route? It's just a few clicks in a software program. But you know, some of the biggest advantages are actually for the human workers. They take over the boring, repetitive tasks, and more importantly, they make the workplace way safer by handling all the heavy and potentially dangerous lifting and moving. And just like that, our puzzle is solved. It's pretty cool when you think about it. We've gone all the way from a patch of empty land to a smart, efficient, automated facility. We started with that huge decision of where to build. Then we zoomed into the tiny details of the layout. We figured out the flow of movement, and we capped it all off with a layer of intelligent automation. This whole journey leaves us with a pretty mind-bending question to chew on. We've seen just how logical and data-driven this whole process is, right? So, as our factories get even smarter, as they collect more data and become more automated, who do you think will come up with the next big breakthrough in design? Will it be a brilliant human engineer, or will it be an algorithm that can see all the pieces and solve this massive puzzle in a way we never could?